Have you ever pondered the mysteries of the universe and asked, what's holding all of this together? Well, the answer, seemingly ripped straight from a science fiction novel, is dark matter, an invisible, undetectable substance that, despite its elusive nature, makes up a whopping 85% of the universe's mass. It's like the universe's invisible glue, holding galaxies together and providing the framework for the cosmos. Now you might be thinking, wait a minute, if it's invisible and undetectable, how do we even know it's there? That's a great question, and it's one that scientists have been wrestling with for decades. Here's the thing. Although we can't see dark matter or detect it directly, we can infer its existence through its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Imagine it like this. You're in a pitch-black room and you can't see anything. But you can feel the presence of furniture around you because you keep bumping into it. That's kind of like how scientists feel dark matter. We observe galaxies spinning at speeds that should tear them apart, yet they hold together. We see light bending in ways that can't be explained by the visible matter alone. We notice that the distribution of galaxies across the cosmos isn't random, but forms a kind of web. All these observations and more point to the existence of something unseen, something massive, exerting its gravitational influence. That something is what we call dark matter. It's the invisible scaffolding upon which the universe is built. It's the mystery that keeps astrophysicists up at night, and the puzzle that we're still trying to solve. So, if we can't see it or touch it, how do we even know dark matter exists? Well, stick around. The story of dark matter is full of twists and turns, and we're just getting started. The evidence for dark matter might not be visible to the naked eye, but it's there, hiding in the shadows of our observations. Imagine a cosmic sleuth hunt, where we're trying to spot the unseen, guided only by the indirect effects it has on what we can see. Take the rotation of galaxies, for example. According to the laws of physics, stars at the outskirts of a galaxy should move slower than those near the center, much like the outermost horses on a merry-go-round. But that's not what we observe. Instead, stars at the edges of galaxies are spinning just as fast as those nearer the core. This suggests there's more mass in the galaxy than we can account for, keeping these outer stars in check. Now let's turn to gravitational lensing, a phenomenon where light from distant galaxies is bent and distorted as it passes through the gravitational field of massive objects. Sometimes, this light is warped far more than the visible mass should allow, implying there's something else, something invisible, adding to the gravitational tug. Then there's the cosmic microwave background radiation, or CMBR, a relic from the early universe. This radiation is not uniform, but has tiny fluctuations in temperature. Scientists believe these fluctuations were caused by dark matter in the early universe, affecting the distribution of normal matter. These are just a few pieces of the cosmic puzzle suggesting the presence of dark matter. Without this invisible mass, many phenomena in our universe simply wouldn't make sense. It's like we're seeing the footprints of a ghost, an unseen entity leaving its mark on the cosmos. These phenomena give us clues, but what might dark matter actually be? As we venture further into the mysteries of the cosmos, we eagerly anticipate unmasking this cosmic phantom. But for now, we continue to gather evidence, piecing together the enigma that is dark matter. Dark matter remains one of the biggest enigmas of modern science, but that doesn't stop us from developing theories. As we delve deeper into the cosmic abyss, we come across some fascinating hypotheses about what this elusive dark matter could be. Let's begin with one of the most popular theories, the existence of weakly interacting massive particles, or WIMPs for short. These hypothetical particles are thought to have about 100 times the mass of a proton, yet they barely interact with anything, making them notoriously tricky to detect. WIMPs are considered a strong candidate for dark matter because they fit neatly into the framework of the standard model of particle physics. Next, we have axions, another class of hypothetical particles. Named after a brand of laundry detergent, axions are predicted to be incredibly light, nearly 1 billion times lighter than an electron. If they exist, they could be floating around us in enormous quantities, yet their weak interaction with ordinary matter makes them extremely hard to catch. And finally, we consider neutrinos. These elusive subatomic particles are a known quantity. They are produced in vast numbers by the sun and other cosmic phenomena, and they zip through space, barely interacting with anything. However, the ordinary neutrinos we've detected so far are too light to account for dark matter. This has led scientists to propose the existence of a heavier type, known as sterile neutrinos. However, it's important to remember that all these particles, WIMPs, axions, and sterile neutrinos, are hypothetical. They are the products of mathematical models and theories, and despite our best efforts, none have been directly detected to date. This doesn't mean they don't exist, though. It simply means that we haven't found them yet. And that's what makes the search for dark matter so exciting. It's a cosmic detective story, with scientists worldwide playing the role of the hard-boiled investigator, looking for clues in the vast expanses of the universe. The hunt to identify dark matter is on, and scientists worldwide are on a quest to detect it. The thrilling chase will continue until the dark matter enigma is finally solved. But until then, the mystery of the unseen remains. From deep underground labs to space-based telescopes, the race is on to make the first direct detection of dark matter. Scientists around the globe are engaged in this cosmic quest, using various ingenious methods to catch this elusive entity. The Large Underground Xenon Experiment, or LUX for short, is one such attempt. Nestled a mile beneath the Earth's surface in a former South Dakota gold mine, LUX is shielded from cosmic rays and other interference. Here, scientists have created an environment so quiet that even a single dark matter particle interacting with the xenon atoms inside the detector could be noticed. Imagine trying to hear a pin drop in a bustling city, and you'll have an idea of the challenge they face. But the hunt for dark matter isn't confined to our planet. Space-based telescopes also play a crucial role. The Fermi Gamma Ray Space Telescope, for instance, scans the cosmos for high-energy gamma rays that, according to some theories, dark matter particles might produce when they annihilate each other. Then there's the Alpha Magnetic Spectrometer, a particle physics detector on the International Space Station. It searches for unusual cosmic ray patterns that could hint at the existence of dark matter. These experiments, and many others like them, all share a common goal: to catch dark matter particles interacting with regular matter. It's an ambitious goal, considering that dark matter doesn't interact with our universe in the ways we're used to. It doesn't emit, reflect, or absorb light, making it invisible to our eyes and our instruments. This is why we call it dark. But even though we can't see it, we can see its effects, and that's what these experiments are trying to capture. They're trying to detect the ripples in the cosmic pond, the echoes in the universal orchestra, the shadowy fingerprints of the unseen. While we have yet to detect dark matter directly, the search continues, and with it, our understanding of the universe expands. Dark matter, invisible yet omnipresent, continues to baffle us, even as we gather more evidence of its existence. In the grand tapestry of the cosmos, dark matter threads itself through, unseen but undeniably present. This elusive substance, seemingly paradoxical in its nature, makes up about 27% of the universe. Despite its invisibility, it exerts a gravitational pull that holds galaxies together and shapes the cosmic web of the universe. Our understanding of dark matter is built upon a plethora of indirect evidence. From the way galaxies spin at speeds that should tear them apart, to the gravitational lensing effect where light bends around invisible mass, dark matter's invisible hand is felt. These observations point to a hidden mass in the universe, a mass we've come to know as dark matter. Theories abound on what this mysterious substance could be. Some believe it's made up of undiscovered particles that don't interact with light or normal matter, hence its invisibility. Others suggest it could be a form of exotic matter or even higher dimensional phenomena. Each theory is a piece of a puzzle we're still trying to solve, a puzzle that could rewrite our understanding of the physical world. In labs around the world, scientists are striving to detect dark matter directly. They're building detectors deep underground, shielded from cosmic rays, in an attempt to catch a glimpse of this elusive substance. Each experiment is a step forward in our quest to unravel the dark matter enigma, bringing us closer to understanding the true nature of the cosmos. As we continue to explore the cosmos, dark matter serves as a constant reminder that there is still so much we have yet to understand about our vast and mysterious universe. The dark matter enigma pushes us to probe deeper, to question more, and to strive for a greater understanding of the universe we call home. As our journey through the cosmos draws to a close, we'd like to thank you for joining us on this exploration of the enigma that is dark matter. This invisible yet omnipresent substance continues to baffle and bewilder, pushing the boundaries of our understanding and igniting our curiosity. It's a reminder of the vast mysteries that the universe still holds, waiting to be unraveled. We hope this video has sparked your interest and deepened your appreciation for these cosmic enigmas. If you've enjoyed our voyage through the cosmos, please consider liking this video and subscribing to our channel. Your support allows us to continue creating content that explores the fascinating mysteries of the universe. We'd love to hear your thoughts on dark matter. Do you have any theories of your own? Or perhaps there's another cosmic mystery that's been on your mind? Leave a comment below and join the conversation. Let's continue this quest for knowledge together. Thank you for watching, and until next time, keep looking up. Remember, the universe is vast and full of wonders waiting to be discovered.